All right. Good morning, geometry. I hope you're having a great day. It is 12.5 time, 12.5a. What we're going to learn today is some very basic trigonometric identities, and this should help you in the future going forward. Now, if you remember all the stuff we've been learning with the different cosine is x, and sine is y, and you add those together. And so basically we talked about that. We kind of reviewed a little bit of that in the class period time. What I'd like you to think about is, as we kind of think through each of these cosine, each of these sines, and you start adding stuff together. And what we're going to learn today is what some identities or some properties that are true about trigonometry. And this is going to come in handy as we do some proof work here going forward. So let's think about this for a second. What would it be? What would sine squared x be of 30? So remember, let's talk through what is sine 30. Sine 30 is equal to 1/2. Good, you guys should all have this memorized. You can be just quoting them back to me. What would cosine 30 be? Square root of 3 over 2. Good, all right, so now, if I were to square both of those, so let's say I square this one, what do I get? 1/4. Good. If I square this one, what do I get? 3 over 4. Add those together, what do I get? 1. Notice that it comes out to equal 1. That's pretty cool. How about this one? How about sine 45? This is one we know. How about cosine 45? Review very quickly. Square root of 2 over 2. Square root of 2 over 2. If I square them, what do I get? 1/2. 1/2. Add those together, what do I get? 1. Notice that when I square cosine and I square sine and I add them together, I always get 1. Now, that's going to come in handy, and here's why. Remember, this is our x, this is our y, and this will be our r. What does that stand for? Go back to our vector. R squared equals x squared plus y squared, or our Pythagorean theorem, a squared plus b squared equals c squared. Now, plug in cosine. Remember, sine and cosine. Here we go. It's going to look like this. Sine squared x plus cosine squared x equals 1. This is the Pythagorean identity. Okay, so the Pythagorean identity. So you got to memorize that. And the cool part about that is you might need that in multiple different ways. What's another way to write that Pythagorean identity? Sine squared x equals 1 minus cosine squared x. Cosine squared x equals 1 minus sine squared x. So that's another way of writing the Pythagorean identity. So remember that as you kind of look at these different things and see them coming up. Now, as we learned this before, if I have a triangle, and this is, let's say, A, B, C. Across from the A is the little a, across from B is a little b, across from C is a little c. If I were to say to you, give me what sine A is. Sine A is equivalent to opposite, little a over C. What would cosine A be? Would be adjacent, which would be B over C. And everybody remembers those concepts, right? Any questions on that? Now, let's think about that for a second. If I want tangent A, what would that be equivalent to? Well, what would you say? Opposite A over B. Good. Now, let's think that through for a second. What's another way to write tangent A? Or tangent, an identity? Think with me. What if I were to take tangent A and make it equal to sine A over cosine A. What would that do for me? Now think about it. We have sine A, we have cosine A. What happens? Sine A, what does that become? Think about it. It's going to be A over C over cosine, which is B over C. So essentially, that is AC over BC. Multiply by C over B, multiply by C over B. These cancel out. Tangent A equals, class, A over B. Sound familiar? It does. So, another thing that you need to remember is tangent A is represented by sine A, or we'll say X, so no confusions there, cosine X. Sine X over cosine X. Good. Now, let's do two more. Or three more. Three more reciprocal trig identities. Three identities or trig ratios. And here's what they are. These are secant, cosecant, and cotangent. Okay, cotangent. So x, x, x. Okay, so secant actually goes with cosine. So another way to write that is 1 over cosine A, or cosine x, sorry. Cosecant is the opposite of sine, which is 1 over sine x. And cotangent is really 1 over tangent, or cosine x over sine x. Okay, so these are the things you need to memorize from this lesson right here. So this is the memorization. These are the identities that are going to help you solve these problems. They're going to help you solve these problems. So we're going to do two examples, and then you can work on those first couple sets of examples. And then we'll come back and do 12B. We'll do the second section. I'll do 3 or 4 more examples for you, help you that way, all right? So the first one, secant, our sine x, secant x equals tangent x. So what we're trying to do is we're taking the most complex side of the equal sign, and we're going to manipulate it. We're going to change it with the identities that we have, and we're going to make it so that it will say and give you the answers that you need and want, okay? So, which is the more complicated side? Tangent or sine and secant? Well, of course, the one that has more than one is probably that side, right? So here we go. So sine x cosecant x equals tangent x. This is always going to stay the same. It's like equals. You don't do anything on this side. You just keep taking it down. This side we're going to manipulate. So sine x is what it is. We don't want to do anything with that. However, what's another way to write secant x? Very good. 1 over cosine. So sine x times 1 over cosine x equals tangent x. Because remember, I don't change this side, I only change this side. Now what? Well, I put sine x over cosine x equals tangent x. Okay? What do we know sine x and cosine x become? Tangent x equals tangent x. And we're done. So what we're doing is we're doing this proof. Step 1, step 2, step 3, to prove that these two things are saying the same thing. All right? That's a fairly basic one. But let's try a different one. All right, let's try a different one. All right. 1 plus cosine x, parentheses, 1 minus cosine x equals sine sine squared x. So remember, once again, let's keep the one side that has one thing and manipulate the other side. So when you see a problem like this, we have to do what's called FOIL. First, 1 times 1 is 1, minus cosine x plus cosine x minus cosine squared x, all equals sine squared x. Now, what happens here? These subtract. 1 minus cosine squared x equals sine squared x. Well, remember our identity we had on the board? This becomes sine squared x equals sine squared x, and we have arrived at our destination. So that's the kind of examples we're doing, and that's the goal behind these trig identities, is to plug in and do, okay? So I'm gonna do one more example, and then I will do a couple 12.5 homework problems to help you, okay? So here we go. Cotangent squared x plus 1 equals cosecant squared x. So, step 1, what do we do? What do we do? First step, what's a way to write this out? So technically this is what? Tangent, right? Or what's cotangent? Break cotangent down. Cosecant. What over what, guys? So it's going to be cosine squared x over sine squared x plus 1 equals cosecant squared x. All right? Now what? Well, I gotta make a common denominator, right? In order to do any work here, I have to have a common denominator. So what do? Cosine x plus sine squared x over, all of it over, sine squared x. Well, could somebody help me? What was this top Pythagorean theorem? Cosine squared plus sine squared is 1 over sine squared x, which becomes cosecant squared x. And we have it worked perfectly for our trig identities. Thanks.